Welcome to this episode of AI Frontiers, exploring machine learning breakthroughs. This presentation synthesizes 49 papers from November 28, 2025 to November 28, 2025. Latest advancements in algorithms that learn from data are examined, with a focus on efficiency, adaptation, and real-world applications. The content is presented by AI Frontiers. This presentation provides a guide to cutting-edge machine learning. 49 recent papers on machine learning innovations are dived into. Themes such as efficiency, adaptation, and physics integration are uncovered. Key findings, methods, and standout studies are highlighted. Future directions and the synthesis process are explored. A narrative on AI's evolving role in society is engaged with. Computer science machine learning, often abbreviated as cs.LG, forms a cornerstone of artificial intelligence. Algorithms are created to learn patterns from data, enabling predictions and decisions without explicit programming for every scenario. This process resembles teaching a child to ride a bike through practice, falls, and adjustments based on feedback. Applications in healthcare, finance, and climate modeling are powered by this field. Challenges in efficiency, transparency, and real-world integration are addressed. Significance lies in transforming data into ethical and accessible intelligence. A prominent research theme involves efficiency and cost reduction in AI operations, particularly for inference and deployment on edge devices. Computational costs are slashed while high performance is maintained on tasks like math reasoning or multimodal processing. Hybrid architectures, as explored in papers such as those on LFM2 and PerfMamba, enable this. The theme overlaps with sustainable AI, where algorithmic efficiency improves 3 to 5 times per year, independent of hardware gains. Deployment on smartphones and IoT gadgets becomes feasible without reliance on massive data centers. Support comes from analyses of algorithmic gains in benchmarks. Another key theme centers on test-time adaptation and online learning, where models evolve in real time without full retraining. Adaptation occurs during inference, allowing smaller open-source models to tackle open math problems like circle packing. Theta Evolve exemplifies this through in-context learning and reinforcement at test time. Access to advanced optimization is democratized. Intersections with reinforcement learning support dynamic environments. Evidence shows open-source models surpassing state-of-the-art bounds on unsolved problems. Physics-informed and constrained learning represents a significant theme, blending machine learning with real-world laws for tasks such as simulating fluids or predicting material properties. Physics-informed neural networks are used for thermal conductivity estimation, while Corgi enhances graph neural networks for Lagrangian simulations. Multimodal methods handle diverse inputs like text, images, audio, and signals. NECG employs a mixture of experts for electrocardiogram analysis. Accuracy is boosted in engineering and materials science through these approaches. Explainable AI and interpretability form a central theme, ensuring models are not treated as black boxes. Bangla SentNet incorporates a hybrid framework for multi-aspect sentiment analysis in low-resource languages, using tools like SHAP for feature attribution. Causal reasoning and robustness are addressed, with tools like Causal Profiler generating synthetic benchmarks for evaluating what-if scenarios. Crawdad utilizes dual-agent debates to refine causal inferences. These elements build trust in high-stakes applications, intersecting with robustness for policy and medical decisions. Several key findings emerge as game changers. Algorithmic efficiency shows costs for top performance dropping 5 to 10 times annually, with pure gains tripling efficiency yearly. Theta Evolve demonstrates modest open-source models surpassing state-of-the-art bounds on math problems through test-time evolution. Physics-embedded networks achieve mean absolute errors under 5% in thermal property predictions from non-invasive data. In multi-agent systems, Emergent coordination phases are mapped based on agent density. Neurosymbolic systems deliver 85 to 100% coverage in epidemic forecasting with human-readable explanations. Dual-agent debates improve counterfactual accuracy from 68% to 80%. Common methodologies across the papers include transformer-based architectures, which use attention mechanisms to process sequences by focusing on relevant parts. Strengths lie in capturing long-range dependencies for tasks like time series forecasting, though they are compute-intensive. Reinforcement learning involves agents learning via rewards from trial and error, applied for adaptive scenarios, but potentially unstable without shaping techniques. Physics-informed neural networks embed equations for higher accuracy with less data, yet they are sensitive to inaccurate assumptions. Ensemble learning combines models for robustness, ideal for multimodal data but resource-intensive. Bayesian optimization tunes parameters efficiently in uncertain environments, though it scales poorly in high dimensions. The first selected paper is titled Theta Evolve, Test Time Learning on Open Problems by Wang et al., 2025. It is chosen for democratizing AI through open-source adaptation. In-context learning and reinforcement are leveraged for math optimization using models like DeepSeek R1. Baselines are outperformed on tasks like circle packing with new bound set. Impacts extend to drug discovery and logistics through on-the-fly evolution. The second selected paper is titled Bangla SentNet, an explainable hybrid deep learning framework for multi-aspect sentiment analysis with cross-domain transfer learning by Islam et al., 2025. It is selected for promoting inclusivity in low-resource languages like Bangla. A hybrid ensemble of LSTM, BiLSTM, GRU, and Bangla BERT is built, incorporating SHAP for interpretability in e-commerce reviews. 85% accuracy and 0.88 F1 score are achieved, with strong few-shot transfer. Business insights are enabled for underrepresented communities. The third selected paper is titled Corgi, GNNs with Convolutional Residual Global Interactions for Lagrangian Simulation by G et al., 2025. It is chosen for bridging simulations in fluids and engineering. Graph neural networks are hybridized with convolutions to add global context. Error is reduced by 57% with only 13% more inference time compared to baselines. Real-time and sustainable scientific modeling is enabled. Future directions in machine learning research include expanding hybrid neurosymbolic systems to areas like climate modeling for better context awareness. Focus on edge devices is anticipated, incorporating quantum-inspired optimizations for lower costs. Ethical benchmarks for causal AI are to be developed to prevent misuse. Data scarcity and bias in low-resource domains must be addressed. Sustainable and frugal AI is pushed to reduce environmental impact. This presentation was synthesized using AI tools including GPT-Grok with model Grok 40709. TTS synthesis was performed via OpenAI for audio elements. Image generation utilized Google tools for visuals. Human expert review ensured accuracy. Potential oversights are acknowledged with all references provided. Subscribe to the AI Frontiers YouTube channel for more AI insights. The channel title is AI Frontiers. Its description highlights diving deep into the latest breakthroughs in artificial intelligence research, straight from the arXiv preprint server archives. Updates on machine learning innovations are provided. Hit subscribe and turn on notifications today. In this podcast, the latest breakthroughs in computer science and AI are brought straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified to keep listeners ahead. Whether a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If this episode was enjoyed, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.